Okay, we are going to now address, again, I didn't get any specific questions, so I did the analysis on test number 5 with a calculator, and I'm going to go over the most frequently missed problems. Good news, there is not as many as there were on the no calculator portion, so that's encouraging. What you want to have is your calculator out, though, because this is a with calculator test, so we don't want, it's more thinking about the mathematics and the relationships and maybe coming up with the equations rather than doing the computation. So we want to, like in most instances, come up with the expression that is going to give us the answer they're looking for and then type that whole thing into our calculator all at once. Again, this test also begins with all of this good reference information. So you can flip back to this sheet in your test to make sure that you are using the correct formula for these ones here. Our volume, we've got our special right triangles, Pythagorean, and some area calculations. Right, the first one that we really need to look at, which this is really exciting, isn't until number 22. And that is a two questions relating to some information presented in a table. So I'm going to guess because of the reading piece of it, maybe that this is why this problem was so difficult for a lot of us. All right, so it says we've got a realty group investing in 5 different properties. Here are the properties. And the table shows the amount in dollars the company paid for each of the property and then the rent that they're choosing in dollars for each of the locations. Now we want to look at the relationship of the monthly rental price in dollars. So they're using an R to represent that. So I'm going to go to the table and put the R on the table. And the purchase price of the property, which is P in thousands of dollars. Purchase price. So this is already, so this is $128,000 dollars. So we would add 3 more zeros onto this. But for computation, we don't need to consider that right at this moment. So we want, they tell us that this relationship between P and R, the rent that they charge, is a function of the price they paid for the property. And it's linear, so it should look like what we're used to, y equals mx plus b. So what we need to figure out for this relationship between r and p is what is the slope, the change in the rent, given the change in the price. That's going to give us our slope. And then what would be our y-intercept if it comes to that. But it looks like each one of these are unique in their slope. So I feel if I can figure out the slope, then I should be golden. It'll lead me right to the correct relationship, linear relationship here. You can choose whichever pair you'd like. I think I would just use these first 2 to get my slope. So you want to take the difference in the rent over the difference in the price. And you got to do the same order. You have to match up the correct X with the correct Y here. And then now we get the calculator. And we're going to type in that entire expression. So we get our, let me see if I can shrink this down a little bit. I'm just going to hide that, sorry. We're picking this fraction setup, and then we are taking 950 minus 1310 over 1281230, subtract off 1761230, enter. Now they don't give me, there is no fraction, so I'm going to do that division to get its decimal equivalent, because all my answer choices are expressed as decimals, and I get 0.0075, which doesn't look like an answer choice, but actually it is, because we want to remember that this is in thousands of thousands. But even if I didn't understand that, I think I would still just match up the one that I got. I'm like, this is the only slope that looks remotely like what I'm getting as far as numbers, so D has to be the correct answer. Right. The follow-up question is, they purchased the Glenview Street property. So then I go back. And now I'm just focusing in on the Glenview Street property. And they said they received a 40% discount off the original price with an additional 20% off the discounted price because they used cash to pay for this property. So the $140,000 that they paid for this property was calculated with this discount scheme off of the original price. So let's just write down, because that's what we're looking for, is the original price. Now, what I think is helpful is to think about not how much money was taken off the price. While that's important, I mean, it's what we didn't pay. I think we should focus on what we ended up paying, because that's going to give us the original price. So if we got a 40% discount, that means I only paid 60% of that original price. But then they said we got an additional 20% off, which means that I only paid on this discounted portion 80%. And now I think what we need to do is we need to solve for the original price. So we would divide both sides by the 0.6 and the 0.8. And then now we get our calculator, and this is what we put into our calculator, that expression that's going to give us our answer. So again, we're going to set up our fraction format and put in the 140,000 divided by our 0.6 times our 0.8. And we get this 291,666, and the closest answer choice to our calculation is going to be choice B. All right, we do need to talk about 25. I think this one was tricky because of the wording with the first 300 and second 300, or the first 150 out of the 300, I think may have led some of us down the wrong path to pick the wrong thing. So we have an experiment to study the tendency of a person to select the first item when presented with a series of items. In this experiment, 300 people were presented a set of 5 pictures arranged in random order. Each person was asked to choose the most appealing picture. Of the first 150 participants, 36 chose the first picture in the set. So we've got 36 out of our total 300 are picking the first picture. Okay, of the remaining 150, P people choose the first picture in the set. So then we've got P more people out of the total 300 that also pick that first one. And this is happening. This happens and this happens. So that's an additive situation. And it says if more than 20% choose the first picture, what would a good value of P be equal to? Or what expression would we use to solve for P? So we need this plus this to be greater than 20% or 0.20. Well, we've got a common denominator, so we could rewrite these two fractions as one fraction, 36 plus P over 300 is greater than 20. Remember, we want to get P in terms, or like solve for P, although I'm noticing there's 2 that solve for P and 2 that don't have P necessarily isolated 100%, but none of them have a fraction. So I think I'm going to eliminate the fraction right away. So then I have 36 plus P is greater than 0.20 times 300. And I might just stop right here and right now and see if I have any expression that matches the one that I just wrote down. And I absolutely do, because that's D. So I don't have any more work required on this problem. All right, number 26. It says the surface area of a cube is 6 times A divided by 4 square, where A is a positive constant. Which of the following gives us the perimeter of the face of the cube? So I think we maybe should draw a cube first to kind of get our brain thinking about the situation, what exactly they're talking about. Once I do that, I notice where the 6 comes from. The 6 comes from the number of faces or surfaces. There's a top and a bottom, a left and a right, a front and a back. That means each face then must have the area of A to the 4th squared. When we know the square, every side's the same. That means each side is an A divided by 4. And now that I'm talking about perimeter, I need 4 of these A divided by 4s. 1, 2, 3, 4. And that is just equal to A. So my suggestion for this problem is draw yourself a picture. Oftentimes, without you even knowing it, it's going to have your brain start working on some ideas and will lead you to the path to solve. Okay, number 29. I think this is probably the most difficult problem on the test because it requires us to do something that we don't do a lot of, and that is completing the square, because this is the equation of our circle in standard form. We want it to be in our form where we can identify the transformations easy. And by the transformations on a circle, there really isn't a whole lot. The 2 components are the center and then that equidistance from the center. And in this problem, we just need to get the coordinates of the center. So all I really need is to rewrite it to get the h and the k. I'm not even concerned about what the radius of the circle is. So the technique here is we need to complete the square, which means we want the x terms together. And we're going to skip some space here. And then we want the y terms together. And we're going to skip some space, and then we leave the constant over here. To complete the square, what we're trying to do is write these terms as this perfect square binomial and write these two terms as a perfect square binomial. To get to that, we have to have a perfect square trinomial. So I need a third term for each of these expressions. And the way I get that third term is I take half of that middle term, which would be 10, and then I square it. Now, if I was doing this to get the equation, I would have to continue to keep things balanced by adding 10 squared to the other side as well. I'm going to take half of 16 to get 8, and then I'm going to add 8 squared. And I have to add it to both sides. And now here's where the rewrite comes. That squared is going to appear on the outside of the parentheses, and I'm going to have my plus 10. So notice inside the parentheses, I just have an x and a 10, and then that whole quantity is squared. Same thing happens here. I have a y plus an 8 quantity squared, and then that equals this negative 20 plus a 100 plus a 64. But again, in this problem, I'm not interested in that. I'm just interested in the center. And the center here, my h is negative 10 and my k is negative 8. So my center is b, negative 10, negative 8. Number 30. In this equation above, a is positive, and the graph of the equation in our xy plane is a parabola. What is an equivalent form of this equation? And this is where our factoring really comes in handy. We want to recognize the structure of this quadratic as the difference of two perfect squares. And you're like, well, wait a minute, Ms. Fasola, that a is not squared. And I would agree with you, but it doesn't need to be for us to fit it into this structure. So x squared is definitely x and an x. One has a plus, one has a minus, and then remember our technique is square root. Square root. And then I pick the answer choice that matches my factoring, and that would be B. Another way to do this problem, although it's more time consuming, is you could expand each of these to see if that match this one. Clearly this is not going to match, because if we do the math here, we get x squared minus a squared. Here, if we do the math, we will get what we started with, an x squared minus just an a. And at that point, you could stop. You wouldn't have to do these two, because it's saying there's one answer and one answer only. It's not a circle all that apply. All right, we can skip 31. Great job with the proportions. And we're going to go to 32. This one is a really easy problem. And again, the strategy should be whenever we're talking about some sort of shape geometry thing is to give yourself a picture. So they're telling us we have a rectangular shape, and its height is 29 inches, and its width is 36.25 inches. And they're going to make a reproduction, which is a third of the original size. Each dimension is a third, and it says what would be the height. So we have to go to the height. That's 29. And then here's our third. And now we get our calculator if we think we need it, but in this point, we have a couple of ways we can express our answer. We could use the decimal, we could use the improper fraction, 29/3, and enter that into the student response. We could do the dividing and get 9 2/3 of an inch. We could enter that in, or we could enter in the decimal. And then great job on the rest of this test. We did a fantastic job with the remaining problems.